Section 8.5 notes day 1 is all about trapezoids. So let's first define what a trapezoid is. A trapezoid is a quadrilateral with exactly one pair of parallel sides, because if there's more than one, then it turns into a parallelogram. So again, a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. A trapezoid has two pairs of base angles. So looking at this diagram, the two parallel lines were the bases, and then in trapezoid ABC, angle A and angle D are one pair of base angles, and angle B and angle C are the second pair of base angles. So again, angle A and angle D are one pair, angle B and angle C are the second pair of base angles. The non-parallel sides are called the legs of the trapezoid. So looking at the diagram again, so again, these are the bases, and the legs are the two sides that are not parallel. If the legs of a trapezoid are congruent, like in this diagram, so again, we have one pair of parallel sides, and then the legs are congruent, then the trapezoid is called isosceles. Just like we had isosceles triangles where we had two congruent sides, if we have two congruent legs in a trapezoid, it's called an isosceles trapezoid. So again, this whole slide is just about all the terminology and how we're going to talk about things in trapezoids. So let's move on to example number 1. Part A says show that ORST is a trapezoid. So looking at the diagram, it appears as though RS and OT are the two sides that are parallel. So in order to prove that RS and OT are parallel, let's just find the slope. So since we're given the picture, we can just use rise over run. So the slope, M, of segment RS would be, I'm going to start at R, I'm counting up 1 and over 2, so the slope would be 1 over 2. And then the slope, M, of OT, I'm going to start at O and count up 1 and over 2, up 1 over 2, so again, the slope is 1/2. I can only have exactly one pair of parallel sides, so I also need to find the slope of RO and ST to show that they aren't parallel, meaning they don't have the same slope. So the slope of RO would be undefined because the slope of a vertical line is always undefined. And then for ST, I would start at S and count down 1, 2, and over 1, 2. So therefore, -2 over 2 is -1. So therefore, I only have one pair of parallel sides, making this a trapezoid. Problem B says, which of the interior angles of quadrilateral ORST are supplementary? So think back to the chapter on parallel lines cut by a transversal, which is exactly what we have going on here. We have RS parallel to OT since they had the same slope, and then they are cut by this transversal RO and this transversal ST. So this angle would be a consecutive interior angle with this angle. Remember, consecutive interior angles are supplementary. So angle R and angle O are supplementary, as well as angle S would be a consecutive interior angle with angle T, since they are formed by two lines that are parallel cut by a transversal. They're on the same side of the transversal, and therefore they're supplementary. So again, angle S and angle T are supplementary, and to justify this, we would use the consecutive interior angle theorem. And something to note, this will always be true. Angle R will always be supplementary with angle O, and angle S will always be supplementary to angle T, as long as we have only one pair of parallel sides in the trapezoid that you're given. And now we have three more theorems. Theorem 814, if a trapezoid is isosceles, so remember, an isosceles trapezoid means we have one pair of bases and then the legs are congruent. Then each pair of base angles is congruent. So as long as your trapezoid is isosceles, so again, that means that the legs are congruent, then the base angles are congruent. So angle B would be congruent to angle C, and angle A would be congruent to angle D. Theorem 815, if a trapezoid has a pair of congruent base angles, so like here, we see we have one pair of parallel sides and one pair of base angles that are congruent, then you can assume that the trapezoid is isosceles. So as long as you have one pair of base angles congruent, you can assume that the trapezoid itself is isosceles. And theorem 816, a trapezoid is isosceles if and only if. So remember, if and only if means I can read this forwards and backwards and they both would be true. So again, a trapezoid is isosceles if and only if its diagonals are congruent. So if I know that BD is congruent to CA, then I could assume that trapezoid ABCD is isosceles. If I'm told that trapezoid ABCD is isosceles, then I can assume that BD and AC are congruent. So again, isosceles trapezoids diagonals are congruent. And now let's look at example number 2. The top of the table in the diagram is an isosceles trapezoid. Find the measure of angle N, measure of angle O, and the measure of angle P. So let's assume that it is this side that is parallel to this side, and we are told that it's an isosceles trapezoid. So that means that this leg is congruent to this leg. That would mean that the base angles are congruent. So angle N would be congruent to angle O, and angle M would be congruent to angle P. So I mark up my diagram with what I know to begin with. So we are told that angle M is 65 degrees. Previously in example number 1, we know that these angles are supplementary since we have one pair of parallel sides cut by a transversal, so the consecutive interior angles are always going to be supplementary. So if angle M is 65 degrees, then angle N would be equal to 180, since it was supplementary, minus 65, which gives me 115. If the measure of angle N is 115 degrees, I know that since it's an isosceles trapezoid, base angles are congruent. So if angle N is 115, then angle O is 115. And then to round this out, the measure of angle P, it is a base angle with angle M, which we were given is 65, so angle P would also be 65 degrees. Recall from a couple chapters ago that the mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. So the mid-segment of a trapezoid is the segment that connects the midpoints of its legs. So in the diagram you can see we have one pair of parallel sides making it a trapezoid, and the mid segment of this trapezoid would connect the midpoint of this leg to the midpoint of this leg. We know that these are midpoints since we see that this segment is congruent to this segment and this segment is congruent to this segment. So again, the mid segment connects the midpoints of the legs of the trapezoid. So given the definition of what a mid-segment of a trapezoid is, now we have theorem 817, the mid-segment theorem for trapezoids. The mid-segment of a trapezoid is parallel to each base. So again, if you know that this is a mid-segment, you know that it is also parallel to each of the bases, and it is 1/2 the sum of the lengths of the bases. So let's just get an example. If I know that AB is 4 units long and DC is 8 units long, then MN would be 1/2 of the sum of those two added together. So 4 plus 8 is 12, half of 12 is 6, so MN is 6. So we're going to be using this theorem in order to find the lengths of the mid-segments in the following example. So here it is, example number 3. In the diagram, segment HK is the mid-segment of trapezoid DEFG. Find the measure or the length of HK. So notice that they gave you that this base is 6 and this base is 18. The length of HK would be half of the sum of those two bases together. So HK would be equal to half of 24, and half of 24 is 12. So HK would be 12, and since we were given a unit here, 12 centimeters long. So again, we're just applying that theorem about the mid-segment. And now on to our last example, number 4. In trapezoid EFGH, if the measure of angle HEF is 70 degrees and the measure of angle FGH is 100 degrees, is it isosceles? So of course, let's start off with drawing a picture. So here we have trapezoid EFGH, and I've marked that EF is parallel to HG. Now let's mark up with what we're given. We are told that angle HEF is 70 degrees, so that's this angle right here. And we are also told that the measure of FGH is 100. So that's this angle right here. And we're asked, is this an isosceles trapezoid? So remember, we know that if these two lines are parallel, cut by this transversal, then these consecutive interior angles are supplementary. So if this is 70 degrees right here, 180 minus 70 is 110. On the same side of that, if this is our transversal, if this is 100, 180 minus 100 is 80. So notice our base angles are not congruent. If the base angles were congruent, then it would be isosceles, but our base angles are not congruent, therefore this is not an isosceles trapezoid. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class, and we'll see you then.